It's interesting. That same argument for Sally Clark I actually used to disprove. A guy was trying to prove the existence of Christ, which I thought was fun. And he came to me. He's like, I want to mathematically prove the existence of God. And I'm like, okay, let's do it. And he said, what he did was he listed out a series of miracles that Jesus, from the Bible. He said, what's the chance they can walk? A guy can walk on water? I'm like, I don't know, 1 in a million? That sounds pretty rad. If you run fast enough, maybe like Ashton Eaton, maybe. Or Michael Phelps, he got size 18. Maybe if he can run, you've seen something called it's a basilisk, some kind of basilisk. It's called the Jesus lizard. It gets a running start on shore and then it runs across the surface of the water. It's not really walking on water. It's actually just using physics to its advantage. But I'm sure you can find a human that can do that. Let's say it's 1 in a million. He's like, okay. How about changing water into wine? I'm like, I'm going to call that 1 in a million too. I mean, I'm sure it's more like 1 in infinity, but let's give it a number 1 in a million. I'm sure somebody somewhere could chemically alter water and make it into wine. Put a grape in it, maybe. So let's call it 1 in a million. He's like, oh, I'm like, okay, hit me again. He said, loaves and fishes. I'm like, oh, that's a good one. That's a good one. Take the basket full of loaves and fish and feed thousands of people with it. I'm like, I bet you with genetic engineering, somebody's clever enough to do it and call it 1 in a million. And he kept naming these miracles. And I kept putting 1 in a millions out there because I'm like, yeah, that's the old phrase. You're 1 in a million. You're 1 in a million. Yeah. And that's totally fine. And then he said, so what is it? I'm like, what do you mean, what is it? He's like, so what's the chance that one person can do all these things? I'm like, I don't know. He's like, sure you do. You just proved it to me. It's 1 in a million times 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 1 in a million. I'm like, why are you multiplying? He's like, because the chance that he can do that, and he can do that, and he can do that, and he can do that is the things multiplied together. It's what we just used right here, right? And I said, well, what are you assuming about all these things? That they're independent of each other. I said, don't you think that if somebody has the ability to walk on water, they might also have the seemingly magic capability of changing water into wine and or multiplying loaves and fishes to feeding thousands of people? He's like, well, yeah. I'm like, then you're not allowed to multiply because you're assuming that there's a dependence and not an independence. And he's like, that's not what I said. I'm like, you just said that. You just said that like 3.5 seconds ago. And he stormed out of my office and never heard from him again. And it was just so great. He's trying to prove the existence of God. I showed him a way he couldn't do it. I didn't say God doesn't exist. I said that you can't do it that way. He got pissed and left. But that same mathematics mistake is the same mistake that was made in the Sally Clark case, although on a much, more innocuous level here. I mean, proving versus disproving God exists. I mean, it's adorable. It's adorable to try to use mathematics to do that. So, I'd rather not, if it's okay with you guys. And instead, I'd rather get back into the gambler's ruin idea. So you've got a pair of dice in front of you. I need us to get familiar with this pair of dice over the remainder of our time together. We're very limited. The remainder of today, which is, oh, the clock is back. About 45 minutes-ish. Thank you, whoever did that. That was driving me insane. So, 45 minutes today, and then maybe the in-class quiz we'll have to do on we'll see. We'll give you part of it today and part of it on Wednesday, maybe. When you throw a pair of dice, you're very often interested in the sum that you get. It's not, on the quiz that you're doing for Wednesday, should you choose to do it, you're interested with how many 5s, I think, come up. So you have 0 or 1 or 2. But most of the time, that's not how you use a pair of dice in gambling. Most of the time, when you use a pair of dice in gambling, you throw the pair of dice and you're interested in the sum that you get. So what I'd like to do right now is construct what is called the distribution of all the outcomes for a pair of dice. Okay? So if you throw a pair of dice, what sums can you get? You can get 12. That's called boxcars and craps. Love that one.
Get 2.
You can get 2. That's called
Snake eyes.
Snake eyes. Ugh. What else can you get?
4.
7? You want to get 7 on the first roll. 7 on the first roll, that's great. What's the chance of it happening? Hold that thought. Good, good. You don't know off the top of your head? That's okay. You will by the end of the day. Mike, you know it already? Good for you. Excellent, excellent. What else could you get? I heard 2, 7, box stars.
All of them.
All of them.
Before 12.
Between 12 and 2, yes?
Yeah.
So, if we're interested, so if you roll a pair of dice, roll a pair of dice. If you roll a pair of dice, the sums that you can get are everywhere from 2 to 12. Assuming that you got 1 through 6 on your dice. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And all of these have fun little names in Vegas. 2's called Snake Eyes, 12's called Boxcars. I forget what the other ones are called. Yeah, the other ones aren't as popular as
10's like mini boxcars.
Mini boxcars or something like that, exactly, exactly. So this is what happens. What's the chance of these things happening? For example, Mike, you told me, what's the chance of 7?
Well, I just took 6 to the power of 6.
Oh, and what's that?
It's 1 in 46,650.
Holy, wait, what? Why 6 to the power of 6? I'm curious.
Because you have 6,
Mm-hmm.
6 different numbers on the die.
So, if I may, you can tell me to stop too. But I'm going to do a tree diagram, at least a partial one, okay? So here's us starting. First roll number 1. What can happen, Mike?
You get 1, 2, 3, 4, 5, 6.
Beautiful. That's roll number 1.
On one die.
On one die. Now how about roll number 2? Now, let's not do this all the way out, mostly because you guys already did it on your last project. You already answered this question that I'm trying to get at here. If you roll a 1 on your first die, what happens on the next one? It could be 1 through 6, can't it? How about if you roll 2 on the...
1 through 6. 1 through 6. 1 through 6.
How many possible outcomes are there when you throw a pair of dice? 36! That's it! You guys already wrote them all out in your last project. I made you, I think it was question number 2, write them all out. I knew we'd get back to them eventually with the craps game. So there are 36 possible outcomes when you throw a pair of dice. Now the first thing you're going to think about is, holy crap, if there are 36 outcomes, how many sums are there? How many, go ahead, say that, be brave.
12.
11 actually. Don't count 1, because 1, you can't get 1. So it's 2 through 12 is 11 different outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 in the 36 doesn't go evenly, does it? 36 divided by 12 divides evenly, but we don't have 12, we have 11. So you can't say something like, you've got a 11/36 chance of any of these things. So again, I ask, what is the chance of rolling 7, or 6, or 5, or 4? So there's a couple ways we can do this. Grab your dice. Let's start at the... Tom?
How come you're only using one die and not 2?
I am using 2, it's just that I didn't bother writing all of these out. Because we're about to do them with our dice ourselves. Grab a pair of dice. Grab your dice.
6 sides.
Exactly, sir. The key for this was, it's out of 36. I know that the probabilities are out of 36 total rolls. So here, I just rolled a 3 green and a red 5. That makes a sum of 8, correct? That particular sum has a 1 in 36 chance of being rolled. But there are 35 other sums I have to account for as well. So let's talk about them right now. Everybody, if you would, take your dice. Everybody have 2 different colors? That's helpful if you do. It's helpful. It's not imperative, but imperative. It's not imperative. It's not imperative, but it's helpful if you do. Make snake eyes. Make a sum of 2. You can try to roll if you want to. That's totally fine. It might be kind of hard. Okay, it might take a while. On average, how many rolls is it going to take? Oh! On average, how many rolls is it going to take you to get snake eyes?
1 in 46,000.
It's not that bad. It's not that bad. It's not that bad. It's 36 rolls on average to get snake eyes. And here's why. Here's why. You're about to see why. Everybody got snake eyes? Make it a different way.
Oh, 6 on 6.
Make it a... Why are you looking at me like that? Because you can't. There is one and only one snake eyes. 1 on one die and 1 on the other. In other words, you just got 2 roosters, each of which was a chance of 1 in 6, yes? So the chance of snake eyes, I'm going to put probability here next to it if that's okay with you guys. Probability. The chance of snake eyes is 1 in 36. Just about 3%-ish, somewhere in there, neighborhood. So why do I say it takes 36 rolls on average to get snake eyes? Because out of every 36 rolls on average, you hit snake eyes once. Which means, thinking about it the other way, flip the fraction, it takes about 36 rolls to hit that snake eyes. On average. Cassie's thinking about it. I love it, sister. I love it. I love it. So over time, you have to roll a bunch. But on average, every 36 rolls is going to be snake eyes. And not every 36 will be a snake eyes, but on average every 30. Yes, it's that damn average again. Yes, so important. So important. I've ruined you guys. I love it. Okay, you ready, Cassie? Ask me that question. You got a question coming?
No.
You sure? You sure?
I'm sure.
Oh, okay, okay. Everybody, let's move on to 3.
10.
Make a sum of 3. Okay, I got it. Okay? Do it again. Make a different sum of 3. Nobody's pissed now.
Can't do it.
Because you can do it, can't you? This is why I told you to get 2 different colors. This is why I told you to get 2 different colors. It only counts as a different roll if you have to pick the dice up and move it around. With snake eyes, you couldn't, right? You got 1 and 1. If I told you to make a different snake eyes, you can't. But with 3, check it out. 1 and 2. Red 1, green 2. There's another way to make 3, isn't there?
Yes.
Red 2, green 1.
Yeah.
So, can we do it again? Any other different ways to make 3? That's it, isn't it?
Yeah.
So what's the chance of rolling 3?
2 out of 36.
2 out of 36. Which, say it, Mike?
1 and 18.
Which means 1 in 18. I'm going to leave it, if you don't mind, I'll leave it like that, just to make things easy. But you just gave me the answer. My next question was, on average, how many times do you have to roll until you see a 3? 18. You have to roll half as much because you're twice as likely to get 3 as you are to get snake eyes. Pretty slick, huh? Fair enough? Good. Bad news, if you roll either of those 2 on your first roll in craps, you lose. 2 and 3, or boxcars for that matter. Those are bad. You don't want to roll those. But we need to know this to be able to play the game effectively. All right, you guys ready? Make 4. A sum of 4. I'm sorry, a sum of 4. Make a sum of 4. How many of you guys did double 2s? A bunch of you. Cool, cool. That's called 4 the hard way in craps. It's got a better payout. It's also hard, because what's the chance? What's the chance of rolling 4 the hard way? 1 in 36. That's the only way to do it. You got to roll 2 and 2. But if you bet on 4, you don't have to roll 4 the hard way. So everybody's got 1 4. Look at it, 1 4, right? I did it 1 3. Make another 4. Good. I'm with you, Deb. I'm with you. I did a 3 and 1 and a 1 and 3. And guess what I didn't do? 2 and 2. So I did 2 and 2, 1 and 3, and 3 and 1. Which I'm assuming you guys did too. Anything else we can do? That's it. That's it. There's 3 ways out of 36 to get a sum of 4. Go, Tom.
On the 2 and 2 though, you can have 2 blue, 2 red, or 2 red.
This is a very good point. Tom's saying timeout rule. Damn it. Why can't we flip? Everybody go to 2 and 2. Go to 2 and 2 with your dice. Thank you for this, sir. 2 and 2. Looking at 2 and 2. Try to get 2 and 2 a different way, and it only counts as a different way if you have to rotate the dice to pick different faces. You don't, do you? It's just like snake eyes. 2 and 2 is just like snake eyes with a sum of 4 instead of a sum of 2. All the doubles are only counted once because you have to get those 2 faces in that order. There's no other 2 somewhere else on the die. Does that make sense? So all the doubles are going to be counted 1 time, where the mismatches are counted twice because you actually do have to rotate those through. On average, we'd have to roll 12 times, right? 36 divided by 3 is 12, so 12. Every 12 rolls, you're going to get a 4. Every 12 rolls, you get a 4. On average. Yes. Okay, 5. 5. Make 5. 4 and 1? I made 4 and 1. Make 5 again. 1 and 4. Make 5 again. 2 and 3. Make 5 again. 3 and 2. Make 5 again. Ah, Jacob's like, to hell with you, I will not. Because you can't. You're stuck after 4, right? 1, 4, 4, 1. We can count those twice because different colors dice. 2, 3, 3, 2. There's nothing else. You can't use 6s. That's too big. And you can't use 1s, or you can't use, crap, I lost that train of thought. You can't use 6s and you can't use 5s. They're both too big. So you use 2s and 3s and 1s and 4s. So there's 4 in 36 or 1 in 9. So every 9th roll, expect a 5 to come through. I don't know which 5, but a 5, right? That's the thing too. When I say every 9th roll expect a 5, I don't mean every 9th roll expect, oh shit, that's 2 5s. Well, that's a 1 in 36 chance.
Yeah.
So every 36 rolls, expect double 5s to come through. Just like snake eyes, just like double 2s, just like double 3s, just like double 6s. But every 9 rolls, expect some form of a 5 to come through. Some form of a 5, not necessarily any particular one. Does that make you see the difference there with how I'm phrasing that? That's why you get paid more in craps when you bet the hard way on things. When you bet 10 the hard way, I would have just won because I rolled double 5s. That's because it's harder to get 10 as a doubles than it is to get 10 overall. There's fewer options. Fair enough? You guys buy that? Awesome. How about 6s? I think you're seeing the pattern, yes? It's going to be 5 and 36. Try to figure out why it's 5 and 36 without turning your dice. It has a hole in it. What's the definition of insanity? Doing the same thing, expecting different results? 4 hours, 3.5 hours I've been doing it. My phone in the pocket, damn marker in the pocket.
I heard
What was
about a
the question?
calculator in the pocket.
Calculator in the pocket, all the way through. What are the 5? Let me hear them.
1 and 5.
1 and 5. 5 and 1. 4 and 2. 2 and 4.
3 and 3.
Double 3. 6 the hard way, right? 6 the hard way. Very nice. Jacob?
So basically, might be jumping the gun a little bit.
Go ahead, brother.
If you were to bet on any, if I were just going to say I'm going to get a double of anything, it would be 6 and 36 or 1 and 6.
It depends if you're betting on doubles or a particular double. Thank you, sir.
But if it's not particular, it's
6
1
and 36.
Yeah.
Which, believe it or not, is the same probability as rolling a 7. 7. My question originally was, what's the chance of rolling 7? It is the most common roll on a pair of dice. Cass already figured it out. Think about why. 1 and 6, 6 and 1. 2 and 5, 5 and 2. 4 and 3, 3 and 4. 6 ways to do it. It's the same as rolling doubles. Double 1s, double 2s, double 3s, double 4s, double 5s, double 6s, double 7s. The reason it's the most popular roll is, no matter what you roll on the first die, there is something on the second die that will make 7 with that. Does that make sense? It's just like doubles. No matter what happens on the first die, there is exactly one result on the second die that will match it. So there's 6. If you look at this tree diagram we kind of half started, this is a given for 7 or for doubles. For 7 or for doubles. As long as you hit this, there's going to be exactly one of these that will pair with it to make a double, 1. Pair with it to make a 7, 6. Exactly 1 will make a double, 2, or a 7, 5. A double, 3, or a 7, 4. All the way down. You can't say that with other sums, can you? They fall short. They fall short because some things, for example, to get a sum of 8, you cannot roll an 8 if you roll a 1 on your first die. Because 1 is too small. Does that make sense? The only ways to roll 8 are what? 4 and 4, 5 and 3, 6 and 2, 2 and 6,
3 and 5.
3 and 5. Look what happens. Look what starts happening. It starts going back down again. Now, if you've looked at the quiz for Wednesday, I actually have an image of all the possible... I'll pull it up on the computer here in a second. I've actually got an image of all possible outcomes for a roll of 2 dice. And it's actually pretty geometric. It answers your question pretty sweetly, Jacob, actually. What's the chance of a 9?
4.
4 and 36. Oh, I forgot to ask my question, but I think you know the answer to it already. On average, how many times do you have to roll till you see a 7?
6.
6! 36 over 6 is 6. Every 6th roll, you're going to see a 7. That's pretty common, yeah? Every 6th roll, you're going to see doubles. You just don't know which ones, right? So 9 was 4 and 36. 10 is therefore 3 and 36. I got 10 the hard way, double 5. You could also get 6 and 4 or 4 and 6. 11. 2 out of 36. 6 and 5, 5 and 6. And finally, boxcars. 1 and 36. Let me share something with you, friends. I was put in the damn pocket again. Let me share the image that's on the quiz for Wednesday, should you choose to look at that quiz for Wednesday. Natasha, would you mind killing those lights back there? Thank you, sister. Oh, there we go. Let's fire up Google. Out comes pair of dice. Yeah, I spelled it wrong. There we go. This'll do. There they are. There's all 36 of them. Now we did one better because we did them ourselves.